Oh, it's okay. Got it. Like this? Ah, got it. Not this smart. Like this? All right. All right. Hold up. So I'm Jared Hansen. I work at Auth0 with some guys here, and they're kind enough to have me down to Buenos Aires for a week. Invite me here to talk about some of the design decisions that went into Passport.js. So who here is using Passport or familiar with it? Okay, so a good number. Good. So this is going to be about the design decisions that went into it. So since a lot of you use it, you'll be familiar with it. Those of you who don't use it, hopefully I'll explain some of it so you understand the decisions and can apply them to your own software. So Passport is an authentication module for Node.js. It's got over 5,100 stars on GitHub and is now downloaded about like 350,000 times per month. So there's quite a few people using it, a lot of big companies and small startups. And one of the things that really makes it popular is that people find it easy to use. So what does that mean? To me, like developer ease of use comes from having clean APIs and good documentation. So I've spent a good amount of effort making Passport have a pretty clean API that's easy to integrate into applications. And then, of course, there's always documentation, which hopefully it's good enough, but documentation is never perfect. So my two main tips to do clean APIs are, one, read this book. Have you guys read that? A long time ago. Oh, I've read it a long time ago too, but once is good enough, I think. Yeah, so I mean, this book really gives like us as software developers a language to like describe the software we're building, and that's super important if you're doing like library or module development where its intended use is to be integrated into a larger application. It's especially true of open source because like oftentimes the developers that use your library don't like communicate with you. So your only way to communicate is really through the structure of your library, and hopefully they understand the patterns as well so they know how to apply them to their own application. The other tip is really just do the simplest thing possible. Software gets really complex. If you're designing an API, you want to whittle it down so it's as simple as possible, which in turn will make it hopefully easy to integrate into an application. The more things you add to it, it's harder to make easy to use, obviously. So those two things, as they apply to Passport specifically, I want to talk about how I went about that process. So the simplest thing possible in terms of Passport is just authentication. And authentication is just the ability to identify a user. And that's really it. So when I first sat down to develop Passport, I kind of wanted one function was my ideal. That's always my ideal. And that's the authenticate function. And the result of the authenticate function should be a user that is authenticated. That changes slightly once you apply it to Node. But basically, this is the simplest sort of application that uses Passport, where you have a middleware that calls authenticate, and then a user is available on the request that you can do things with after the fact. Of course, like once you get into the implementations, there's lots of complications behind that. In authentication specifically, the complications are there a ton of protocols involved. HTTP has a bunch of schemes. There's SSO protocols. OAuth is used in like social networks, SAML for enterprise applications. And this list is constantly growing. For some reason, people like to make protocols. The other problem is that there are lots of providers. So for every protocol, there's a bunch of implementations of it, and you wind up with things like Google having their own way of doing things, Twitter, Facebook, etc. And this is really like the first problem that I tried to solve when I was starting out with Passport is I wanted to basically have an easy way to authenticate both Twitter and Facebook. So the problem is that these providers all have different ways of representing a user profile. Just as an example, like here's two, Facebook and LinkedIn. You know, they serialize things different. Facebook uses underscore notation. LinkedIn uses camel case. Slightly different property names. For instance, for profile URLs, Facebook calls it a link, and LinkedIn calls it a site standard profile request for who knows what reason. But so coming back to design patterns, they give us like a tool to apply to this sort of problem where there's a different way of doing things, and that's the adapter. I'm not going to read these definitions, but if you haven't read the book, you should go get it. Um, and the adapter is all about just converting from one interface to another. And so applying that to the problem with many different user profiles, we just in Passport convert them all to a single schema, and that comes from the portable context schema. Again, going with simple stuff, I like to never define anything new if I don't have to. And the portable context schema was out there, and it was for this purpose, so I just used it directly within Passport. So after applying that within Passport, it will normalize those. So in this case, Facebook and LinkedIn look exactly the same. The schema is the same. You just get different values for IDs and stuff because those are going to differ amongst the providers. But now people implementing social authentication, for instance, with Facebook and LinkedIn in this case, don't have to learn the different ways of doing things with the providers that are out there. They can just do it once, and they know everything that they need to know to work with the others. And this is really like, as simple as it seems, probably the biggest reason that like people like Passport so much is just this complication that it takes away is like enough to really drive a lot of adoption. And so when people use this in their applications, they can just implement one authentication, in this case with Facebook, and then just add social providers without really writing any more code because they've done what they need to. They just change the provider that they use. And after that, all the schema is the same. The second real problem that I wanted to solve with Passport, and this is where it gets more interesting from a technical standpoint, is that applications have a lot of different needs. For authentication in particular, there's a lot of different protocols out there, as was seen on the previous slide. And every application has a different idea of what user database it wants to use. A lot of people have SQL databases or NoSQL databases, MongoDB, Cassandra. Some people just prefer to use LDAP for all their user directories. And it's really hard as like a library author to accommodate all this. And some of the authentication frameworks that I've seen in the past try to be a little bit opinionated about what it means to store user data. And that really adds a lot of the complication to them, in my opinion. It may make it easy to get started with development, but like once you go to maintain your app, you realize the limitation of those decisions because they don't apply well to your own application. So I wanted to try to like keep Passport as simple, going with that single authenticate API, but still allow the application to deal with these two problems. So the design pattern for this is a strategy, and that's directly comes from where Passport gets its own strategies. So the solution is just to encapsulate those details into individual modules, which can be packaged separately and then used as plugins. So strategies in Passport, they're just plugins that you can get separately. They encapsulate all the protocol details itself. So everything that's specifically related to authentication, say with OAuth or SAML, those details protocol-wise are all implemented in the code and the strategy. However, once you handle that sort of detail and the exchange of like whatever the protocol details are, you need to delegate some of the user storage past that to the application. So Passport strategies just take a callback for that. They don't attempt to do any of that inside the strategy itself because that's, again, trying to keep that complication out of Passport and make it easy to use. And then, yeah. Both Express and Connect. I think Express was like 2x at the time, 0.2.x. So, yeah. Yeah. Yep. So I'm gonna actually get to that here in a bit. So is that cool? All right, he's my boss, so I have to answer the question. Okay, so that's kind of the strategies in a nutshell, what they attempt to do, and then they're registered as plugins with passport.use on the main module. So here's the basic sort of recipe for implementing a new protocol in Passport. Now, a lot of people don't do this. I've pretty much implemented most of the standard authentication protocols themselves, and then people will subclass these for providers specifically. But the general rule is to create a new class to handle the protocol details, and that'd be the strategy part. And then the verify callback, which is typically known as, is what delegates all the user-specific handling to the application itself. And generally, those will take like the credentials that are negotiated in the protocol flow and allow the application to deal with it. Some strategies are slightly different, but that's kind of like a protocol-specific implementation. So that translates, in this case, when using the basic strategy, which is just a simple username and password strategy with MongoDB in this case, you can see you just knew up the basic strategy. The protocol details are the same. The verify callback here is just talking to MongoDB to load the user records out of it, make sure the password is valid, and then if that's okay, give the user record back to Passport, and it will flow that through to the application. Now, if you weren't using Mongo, you could implement the same thing. In this case, LDAP is being the backing user store. So you'll get the username and password via the usual HTTP mechanisms, and then query LDAP. Bind is the authenticate, which basically verifies the username and password, and then you can search the user record to get the rest of the information and supply it. Now, the nice thing about this sort of mechanism is you can have your security people implement the verify callback and deal with the user database and security of verifying passwords. And then the application developer doesn't have to care what the user database actually is. So that translates again back to the app itself, which is pretty simple. You just say passport authenticate with the basic HTTP scheme and then implement your logic. This could be using a database as the backend. You have no idea. Someone could switch it later, and then now it's using LDAP. Your code at the application layer didn't change. So that just encapsulates all those protocol details, and people don't need to be aware of it who may not want to. So getting back to Matthias's question, kind of the final problem after encapsulating all the protocol details and normalizing the user profile is how do you add application logic without kind of add authentication without breaking the application logic. Ideally, you don't want this intermixed in everything because authentication becomes so tightly wound up in your application. You'd like to layer it in cleanly. And so here is where Express steps in, and this is not a Passport design decision really, but Express uses this chain of responsibility, which is basically just passing a request through a set of functions. And so just adopts that straight up, and authentication is request handling middleware. So you guys are probably mostly familiar with Express, but just to this was when Express was 0.2.x, this was a pretty big mystery to a lot of people. But this is how Express works, basically. You just define the URL that you want, and then you give it an array of functions, which are known as middleware. And they just take a function signature of rec, res, and next. And as requests come in, those requests will flow incrementally through this whole chain, and the next function is executed when you specifically invoke next. So in this case, as a simple example, you have 4 functions, one of which just initializes a counter and then calls next, and the next 2 increment the same counter, and finally they call next, and we wind up at the last function whose responsibility is to actually respond to the request, in which case it just says the count is 3. We can modify this now. There's no implication that the whole chain has to be executed. Anyone can either halt the chain or proceed based on their own decisions at any time. So in this case, we have the bottom 2 functions which remain the same, but the second function does not call next. Instead, it responds itself. So in this case, we'll just initialize the counter, increment it once, and respond, and the count will be 2, and the following 2 functions are not used. So that kind of like takes some of the mystery out of what Express is doing, and then Passport takes advantage of that to basically, it'll typically be the first middleware in a route that needs authentication. So as the request comes in, Passport Authenticate Basic will authenticate that request, calling out to your user DB that was defined in the verify callback. And then if the verify thing failed authentication, none of the rest of the functions will be called. So it will just respond with 401 unauthorized at that point. If authentication is successful, then it just calls next, and the application can do whatever it wants. So this is kind of typically how my apps sort of work, is I authenticate a user and then authorize that request if I want to check scopes or any other particular thing on that user specifically. Might track some metrics with statsd, and then finally you kind of have the business logic of your application and do the hard stuff like adding one and one. So that to me is kind of like a clean API, and that's what I was going for with Passport, and also learned a lot from Express as well. So like Passport was one of the first Node projects I did, and I read over the Express code quite heavily in doing that. So you'll see a lot of commonality, as Matthias was pointing out. And they both have a pretty clean API, I think, and that's defined by the fact that they both have pretty good encapsulation, they're composable and extensible, although they do it in slightly different ways. Passport's extensibility mechanism is through the use of plugins and the strategies. And then it's composable by using those strategies in Authenticate. So here you can see that a lot of people do this. Well, they'll start out with just username and password, basic authentication. And then once they kind of move on from that, they'll implement OAuth and bearer tokens. And then you can support both as well by using multiple. And Express is extensible through middleware, which is, again, the rec-res next that we've seen. So you can write your own functions. Passport Authenticate is the function which returns middleware. So internally, that will return a function that has that signature. And then it's composable by just stacking those things in an array. So what are the lessons that I kind of learned? One, make the common things easy. And that's really what I started out with trying to do with Passport Authenticate. That was my ideal authentication API. Of course, like that's not always completely achievable. And so you should have a gradual learning curve for more complex features. So like separating out all the protocol specific stuff into strategies has been a huge win for people like adopting Passport, because they can learn from the simple stuff. And then as they add like OAuth or SAML or some of the more complex authentication protocols, they can just go pull in those strategies and read about the details that are specific to those. And that's about all I learned. Hopefully that's useful. You can read more about Passport at passport.js and passportjs.org. And Auth0 has brought me here, so thanks to them. And if you need a job, that's the guy who talked to you, the guy who asked the questions. Sure. Uh-huh. Yep. Mhm. Yeah, so that's a good question. I mean, my typical answer to that is like JSON requests are APIs usually, and HTML requests are oftentimes just web requests and not intended as a typical API. And like one uses sessions and one doesn't most often. Oh yeah, sorry. The question was about composing authentication strategies with respect to different content types, basically, right? Like JSON as an API or HTML as a web page. Um, so that's probably not necessarily a good answer. It doesn't really solve the problem, but like that's always what I advise is just keep those things separate. Like I sort of view it in my own applications, I guess, is if you're going to build an API that's totally stateless. And then if you want a web application, build a web application that calls that API. And then, and that's the sort of layering, and those would be two separate applications. So in the HTML application, you'd typically just use a session-based auth. You'd have like one login route, right? And then cookies would handle the rest. Whereas the API, the credentials will be carried in each request, and those would be authenticated via stateless ones like bearer tokens, basically. Mm-hmm. Yep. Yeah. Oh, I see what you're saying. Oh, okay. So typically how I'll. Oh yeah, yeah. Sorry, this is weird. Uh, the question was how to take advantage of the browser sessions and reuse that authentication that happened there at the API. Is that right? Okay. So what I'll typically do in those cases, and this is kind of like a little bit OAuth like, although don't go through the whole OAuth flow, is that when the person logs in with their credentials, at that time I'll basically get a token for that user that would otherwise be an API token, and I'll record that token in the session, right? So then the web requests as they come in for web pages, since it's associated with the session, I'll just say session.token and I'll pass that along to the API. So it's kind of like, it's the same as if the token was given to like an iOS app or something, a mobile app, right? But you're instead just keeping it on the server with the session, right? He's the organizer. I don't, does he want a t-shirt? I don't know. I want to see this random script run again. Right. So